Now you can. All right, so let's get started. So today, we're done with all the lessons. So today, I'm asking if you have any questions on lab work 14. Well, I'm going to start there. So you're saying no, you did not have any questions on lab work 14, unless you screwed one of the problems up. We'll find out. Anybody else have any questions on lab work 14? Way to go. Way to come to school without a notebook. So when you're done, tear it out and give her a notebook back. That's all. Well, when you're done, then tear it out. So no questions. Yeah. What did I say about 9 and 10? Well, 9 you already did, right? Except it's 30 grams instead of 17 grams. 10 I talked about. It's 2 parts, right? So 9 years ago to today gives you a rate of how the fish decayed. So I'm going to take that rate, K, and apply it for today to the future. So I can give me a time. That's it. That's your 2 parts. Does that make sense? Yes? So that's all that is. It wasn't bad, right?
It took me a minute. I'm not gonna lie.
Just a minute?
No, more like 6 minutes.
With some help?
Yes.
Okay.
Yes. I'm being honest.
I'd rather you be honest than lying.
Some redirection.
Fair enough. What was your question that you're so?
Oh, because I opened the practice test already.
Uh-huh.
Am I allowed, or should I wait till like review day to go over questions?
No. Once we get through lab work 14, I'm going to ask you if there's any questions on the review. But that's why I said to you that we're starting with lab work 14. And then say no to you. But since you wanted reinsurance, there it is. I already said. Okay. So how about if I put it this way? I'm going to tell you guys this. The questions that I've had so far on the review has literally been questions that you guys are having issues answering because you guys decided not to condense your notes. Literally, that's what it is. And I do believe that if you guys condense your notes, then the review was not an issue. And it's funny to me because when I tell you guys to go back to a certain note, you're like, and then you're just like throwing things in air and saying things that doesn't make any sense. So anyways, lab work 14. Questions, 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 questions. So none. Yes. Number 8. What's the issue? What is it asking for? Awesome, percentage. So out of your A is equal to PERT, what of those letters would be considered your percentage? Here. Okay, so based on that, yeah, it would be your K, but I'm looking at A is equal to PERT. Okay. So in that equation that is given to you, what's the R? Which is what percentage? Move the decimal place twice to the right. You just answered the question. I know, very hard. Hard question. Make sense though? Okay. I know, it was like, should it be harder than that? No. Right? The question answered the question for, the question answered gave you the answer. Wow. Couldn't spit that out. The answer gave you the answer. The question gave you the answer. Next question. Lab work 14. Lab work 14. Going once. Going twice. Man, I can't wait to read the what we know on this lab work, since you guys have no questions. Beautiful. Huh? 0, 0, 0, 0. 1, you submitted something. Yay! Good job. It's all right. When I ask people to give me what they deserve, someone that didn't hand it in said 80%. Yeah. Yes. The ones that I didn't grade for lab work 12, I asked you guys what you guys think you deserve based on the answer key and their rubric, and then I just graded it. I just graded it. You're welcome. Yes. Number 1. Oh, for lab work. So, depending on how you did it, right? So, yeah. Well, to be honest with you, so the question was on really number 1 through 6. What should we be writing? Yeah. So, well, here's the thing. If you guys look at 1 through 6, on the lab work, are they all pretty much the same type of problems? So really, all of them should have the same what we knows. You're just going to write it 6 times, right? So we need to know about exponent form to log form, right? We probably need to know, let me see, is there anything like that? We probably need to know the opposite operations on top, right? And we probably need to know the product, quotient, and power rule, right? Not to change a base. We don't need to change a base in there, right? So if you did those 6 problems, and you're like, okay, what are some of the rules that I needed for all 6 of these? Those are probably the rules that you want to write down. Fair? Okay? That's about it on 1 through 6. So whatever you use in 1 through 6, I would write all of those things down and write it 6 times.
So then when you're saying opposite of operations, do you want us to write all of those or just what we're using?
I would write all of them because you see natural log there, you see log base b there, and you see log base 10 there. So I would write all of them.
So I was just doing what I was using.
Yeah. Well, that's the issue, right? Is that we tend to. So one of the things that you guys did, that this semester did for me, is that it helped me kind of refine that rubric to talk about what needs to be written down. So that's one thing that you guys helped me with in terms of saying, all right, let's do these 5 problems. What would be the rules that you can use for all 5 of these? And let's now just write the same thing 5 times, right? just for muscle memory.
Easier explaining it
Correct.
this stuff.
Correct. Correct. You guys help me with that for sure. But that's a great question.
Cool, so we should all get 10 out of 10s if we
If you actually heed my word, yeah.
want to get arthritis in
Yes. See, here's the thing. If you rewrote your notes, you already have the arthritis. But you already know what we know should have already. Or it'd be like working out for the first time after 2 weeks where you're like, man, my hand's sore. Maybe it's not arthritis. Maybe it's just soreness that because you haven't written enough lately. Yes, you're getting cramps in your hand because they actually started writing again. Just saying. Right? This is why I always have to deal with my IT band because my IT band keeps on screwing my leg up. All right, so let's move on to the review. Questions on the review. Scary part is this, is that if I go, how about if I do this? Let me do this. So last class asked me a great question. They said, what is it that you see on these problems that and you start to know like what to do? Okay? And I said to her, well, here's my issue, is that I've done so many of these problems that it's kind of, and it's because I did so many of these problems, is that I start to see things, right? So for example, number 1, I know 27 is a base of 3, so I know I can get the base of the same. Done, right? So I got 3 raised, the left side equals to 3 raised to the negative 3 power. Same base, done. Number 2, I know I can't get the base of the same, so I'm going to use either natural log or common log, right? Just like the second example I did when we did this, right? The third, if I look at that, I know that ln and e are opposite operations, yes? So either I can do one of two things. I can either do the quotient rule, ln of 1 minus the ln of e to the 5th. Or I know that I can rewrite that fraction as e raised to the negative 5 power. ln of e is wash, cancel each other out, so I'm left with just negative 5. My answer. Make sense? Is that fair? If I look at 4, chances are that's going to be a condensing. And in fact, in the direction it says condense. So that's going to be what? ln of a to the 4th divided by b to the 6th. Done. Does that make sense? 5. In my mind, the first thing that comes to mind is, hey, let's convert it to exponent form. So x plus 5 is equal to negative 3 raised, 1/3 raised to the negative 3 power, which is 27. So x must equal to 22. Do you guys see the same thing? So anytime I have this, I always think of converting it to exponent form. So the 1/3 as a base moves over to the right side. So it's 1/3 raised to the negative 3 power. The negative 3 says flip it, so it's 3 over 1 raised to the positive 3 power, which is 27. So now I got x plus 5 equals 27. Does that answer one of your questions? Okay. The other thing is that every time I see e or ln, I always think that I know the opposite operation, which is opposite operation e is ln, opposite operation ln is e. So I always know whenever I see e, I want to isolate the e and take the ln of both sides. So this is going to be 5x equals ln of 3. So x is equal to ln of 3 divided by 5. Done. 7 looks like expanding, and it does say that in the directions. This is very similar to the problem that I expanded, the very first example I gave you. So this is going to be what? 1/4 log base 9 of 7 minus 2 log base 9 of s minus log base 9 of r. Notice that there's 2 minuses in there. Yes?
8 is more than 10.
Okay. 8. Well, here's the scary part about 8. 8 is very much like number 3 on the lab work. Right? So 2 ways of looking at it. One is that I can subtract the log base 2 over to the other side and have the quotient rule. Or I could also make the 1 a log as well. Look at the logs. What base is it? 2. So I can replace the 1 as log base 2 of 2 raised to the first power. I have the product rule on the right side. So I have log base 2 of 2 times x minus 5 equals log base 2 of x plus 1. They both have log base 2. They go away. The inside must equal the inside. Which, no matter which way you do it, you get the same result. Does that make sense? So here, let me... So one of two things. One, yes, you can say log base 2 of x plus 1 minus log base 2 of x minus 5 equals to 1. So you have log base 2 of x plus 1 over x minus 5 equals to 1. So anytime I have that, I think of exponent form. Right? So here's the thing. So the way I teach this, so that people don't have to remember as much, is saying, since this is a rational equation, I want to get the denominators the same. So if you look at the denominator right here, are these two denominators the same? Yes? If the denominator is the same, that means my equation is going to be x plus 1 equals 2 times x minus 5. Make sense? Now, I told you the other way I would do it is converting that 1 to be a log base 2. So that means I'll have right? I have the product rule on the right-hand side. So again, if I have log base 2 of x equals log base 2 of 5, you would say x equals 5, right? Make sense? That means the inside must be the same, so that means I have the equation of x plus 1 equals 2 times x minus 5. Huh, that looks really familiar. Right? And then you solve for x. Make sense? Questions? Over here, I see a base of 12. I know log base 12 of 12 are opposite operations of each other. As long as the bases are the same, they cancel each other out, right? What's the power of that? 1/2. So that's going to equal to 1/2. Does that make sense? We're okay? If you need me to expand anything, please let me know. Okay, so if you look at number 10, I know that I can write 625 as a base of 5. Is that right? Because that's 5 to the 4th. Okay, so on the left side, I got 5 raised to the 4x. On the right side, I would write that as 5 raised to the 1/2. Is that right? But it's in the denominator. So if I pull it up to the numerator, it's going to be 5 raised to what power? Negative 1/2. So here, how about if I put it this way? So the thing that you guys got to understand is this. So the rule here is this. A to the negative n is equal to 1 over a to the positive n. Vice versa, 1 over a to the negative n is equal to a to the positive n. So the way I taught this in intermediate algebra is that if she doesn't like being on the bottom, let her be on top. If she doesn't like being on the top, let her be on the bottom. Does that make sense? Giggle, 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 giggle. Okay? Make sense? So here's the thing, though. When you look at this, she likes being on the bottom. 5 to the positive 1/2. When I pull her up, she's not going to like it, is she? So it becomes a negative power. Negative exponent. Make sense? Because the power of 36 is 1, right? That's the power. The root is a 2. From the very, very beginning, first day of notes. First day. That's the first day of this unit. Yep. So if you look at the 5, what's the power of 5? 1. What's the root here? 2. So that's why it's 5 to the 1/2. So does it make sense that it's 5 to the negative 1/2? Yes. We're okay then? Okay. Number 11, I'm going to guess that's expanding, which it does say expand. Awesome. So that's going to be what? 4 log base a of x plus 1/3 log base a of x plus 5 minus 2 log base a of x minus 2. Right? Product rule on top. Divide is the quotient rule. Subtracting. Yes? This one here, once it says compound semi-annually, I know I'm going to use the first equation, not the second one. Right? Questions there? 13. Exponent form. 64 is equal to b squared. But it wants you to just evaluate. It doesn't want you to actually solve it. But if it did, the b would be 8. Because 8 squared is equal to 64. 14. Ooh, I love it when I see ln and e together. That's a quotient rule, yes? So I got the ln of e raised to the 4th power minus ln of 7. What's ln e of e to the 4th? Huh? Ln of e to the 4th. Just 4. Minus ln of 7. Done. How about 15? Shouldn't. Do you know the opposite operation of ln? E. Yes? So that means I want to isolate what I know the opposite operation of. So since I know the opposite operation of ln, I want to isolate the ln. How are you going to do that? By 6? Awesome. So you got ln of 6x equals to 2. Make sense? What's the opposite operation of ln again? So e raised to the left side e raised to the right side. So it would be e squared on the right side, yes? So 6x is equal to e squared. Divide by 6. Done. Now here's the cool part. Someone actually did it a different way. It was very interesting because I was trying to make their way work, and we made it work. Oh boy. I got a lot of pages to go now. What the? So the way I would have done it is this, right? Right? So this is what someone else did. They decided to use the power rule on the left side. Then they decided to use E. Is that what they did? Yeah. And what's the opposite operation of the sixth power? Or the sixth root? What is the sixth root of e to the 12th? Here, let me help you out. Let me help you out. What's the power? What's the root? Mm-hmm. Like I said, you have free will. $16 looks like I just have to replace the A with 2650, get the E by itself, take the ln of both sides. Right? 17. Ooh, I see E. What's the operation on E? ln. Ooh, cool. So in other words, I got to get the E by itself. So I got to add the 6 over to the other side, take the ln of both sides, and then add the 5 divided by 5. Boom, shakalaka. Yes? Okay, like? Here. How about this? Have we got to that problem yet? Have we got to that problem yet? No? Okay, how about this? When we get to that problem, you tell me that, and then we'll go through the whole calculation. Is that fair? Okay. So 18. What rule do you see? Hopefully product rule, because there's no subtracting. So it's a product rule on the left-hand side, right? So great. So that's going to be ln of the product of those two binomials. And then the right side is ln of x minus 15. Great. So they both have ln's, so they kind of drop out. Or better yet, the inside is going to equal to the inside. Which, actually, you know what? Let's do this problem. Because I have a hard question for you guys now. Let's see how well you guys answered this question. 18. So again, the example I gave before was if I said ln of x equals ln of 5, wouldn't you say that x is equal to 5? Yes or no? If I said ln of x equals ln of 5, would you say that x equals to 5? That means the inside has to be the same, right? So that means I have why did I reject this? Huh? 3 is a positive. I know what he's trying to say. But I want you guys to clarify it because not everybody knows what you're trying to say because they see the 3 being positive. Make sense? So what do you mean by negative? What's the domain of a log? 0 to infinity, not including 0. What does that mean? But that's a 3. That's greater than 0. The best you can.
So what I would do is I would plug what x is into the x minus 6, x plus 1, x minus 15. And you can't do 3 minus 6 because it gives you a negative, but it's going to have to reject total, no solution.
So the domain being 0 to 15, 0 to infinity, not including 0, means that you cannot take the log, the ln, the common log of a 0 or a negative number. If I put 3 back into it, 3 minus 6 gives me what? Negative 3. I cannot take the log or ln of a negative number, period. That is going to give me a flipping me off undefined. Make sense? That's why I have to reject it. So, guys, just because the x is negative does not mean I reject it. Understand that. Until you plug it back in. Because what if this was 6 minus x? Negative 3 would be great. And if this was 15 minus x, negative 3 would be great. Right? That would give me a positive number. So that's the reason why I wanted to do this, because I wanted that explanation to come out. Is that fair? Okay. No. These are all easy. Guessing is condensing. It is. Log base 6 of x to the third times x minus 6 quantity raised to the 6th power. Raised to the 5th power. Log base 6 of x to the third times x minus 6 to the 5th. Right? Because it's product rule. Ooh, this is interesting. 20. What base is the log? 10. So if the base is 10 and the log base is 10, they are opposite operations of each other. They cancel each other out. So it's going to be either the 5th root of x or x to the 1/5. How should I do 21? Make it exponential form. X plus 4 is equal to 4 to the negative 1 power, which is 1/4. How shall I do number 22? Can I make 125 a base of 5? Yes, it's 5 to the third, right? So log base 5 of 5 to the third, base of 5. They cancel each other out, so the answer must be, So for everyone that used in the what we know last lab work and put in the change of base into what we know, this is where the change of base would come into play. Not last week's lab work. Not in condensing, not in expanding, but actually change of base. So the change of base says that you can use the natural log or the common log. So this could be the ln of 26 divided by ln of pi, or the log of 26 divided by log of pi. Ln of 26 over, or you can use log, you just use log, over the log of pi. You can type that in your calculator and you'll get a decimal, and this is asking for 4 decimal places. You probably need to round, yes. But remember, it's going to be multiple choice anyways. So it's going to be 0 point blah, 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 blah. What did you get?
Oh, I got 2 point.
Okay, so 2 point blah, 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 blah. I don't know what it is. It's not. I'm not a natural calculator of logs. This is compound continuously, so that means I got to use the second equation and not the first. Right? I'm still waiting for the problem that you had problems with. Which one?
Just putting it in the calculator. I was putting it pi log.
Oh, that?
Yeah, that was it.
So you know what you did wrong?
Yes.
Okay. 25. What base is this log? 10. So can I write 10,000 as a base of? It's to the fourth. Huh? But it's a base of 10, so you got to rate 10,000 as a base of 10. So it's 10 to the fourth. Right? But what rule is in here? You were saying the right one. Yeah, it's a product rule, because multiplying. Right? So I got log of 10 raised to the fourth plus log of x. So it's going to be 4 plus the log of x. Done. I'm guessing the way you screwed this one up is that you did one log and divided the two things. Yeah. So essentially, whatever you type in, if it doesn't look like what you wrote, then it's wrong. That's why I love Desmos, for that reason, because I can see exactly what's written there.
And we're not going to have any surprise graphs in test 2 because it's not on the practice test.
You answered your own question.
Yeah, I'm just making sure because I get anxiety.
Why would you switch it up?
You never know.
Because Chan's an a-hole.
No, you got to be prepared.
Chan is a communist, right? That's why people raise their hand like this
Oh, wow, that's crazy.
and then do this. He always changes things up just to burn you. Math is so boring, isn't it?
Are you not getting what he's saying?
Yes, I know what he's saying.
She's having flashbacks. Jokes, jokes, jokes. All right, next question. Any other questions, guys? She's like, flashbacks? What do you mean? I don't know. Is there any questions on the review? If Chan would be a little funnier and a little bit better at teaching math, it'd be great. No, Chan. So any other questions on the review? Did that answer all your questions on the review? Awesome. Did it seem hard? So I would say this. So the student that asked me what I was thinking, because they were still nervous about what to do, what's that first step? And the thing I said to them was, it really is just doing more prompts. Yes. Because I did it a lot more times than you did. That's all it is. If you did 1,000 problems, guys, you can teach this class. Because you can already teach this class. You might not be very clear. You might not like ask those other questions like.
Do it, not put any.
Yeah.
I'd be like, why did you get that?
Just get her done. Hopefully that won't be his accent. Just get her done. But yeah, it really is. I think if you guys do enough, when you start to see, you would be like, oh yeah, that's just that. Yep, that's just that. Yep, just that's that. And yes, the lab work is great practice. The review is great practice. But if you only do those, you're going to run into prompts, right? Like doing this at number 25 is great. You remember how to do number 25, but what was question number 8? That's going to throw you off, right? It's those type of things that are going to throw you off. And that's when you're like, I have anxiety. You don't have test anxiety. Well, here's the thing. What is considered anxiety? Anxiety, what's the definition of anxiety? No. No. It is, here, how about, let me put this definition out there and see if this makes more sense. Is there fear of the unknown? Would that be a good example for anxiety? Yes? Good definition? Do you not know what's going to be on the exam?
No, I know that.
Then you shouldn't have anxiety about it, right? But that's what I'm saying. So being nervous about taking an exam is one thing. But saying that you have test anxiety is totally something different, because anxiety is the fear of the unknown, right? Just like if you're going into a haunted house, your anxiety goes up because your fear of the unknown, because that's the first time going through it. But if you went through that haunted house like 10 times, do you think the 11th time you're going to have that anxiety? No, because you know exactly where everything is going to be popping up, right? Right? Unless you walk in and like, everything's totally different. Now your anxiety pops back up. Make sense? So that's the thing that you guys got to realize, is that I don't believe in the test anxiety in my class, because you already know what's going to be on the exam, right? You might be nervous taking the exam because it's an exam and you want to do well. Understood. But if you practice enough, right, of these problems, when you see it, you're going to know how to do it anyways. It doesn't matter what I throw on there. You guys are going to know what to do. So that's the biggest part for me. All right? So any other questions on the review? So nothing. All right. Well, ladies and gentlemen, please have a wonderful, blessed day. Please be safe. Love you guys. See you guys next week.